This is IMO 1968. Question number 1. The question wants us to prove that there's one and only one triangle whose three sides are consecutive integers, and one of those angles is twice as large as another one. So the three sides of this triangle should be n minus 1, and n plus 1, where n is an integer. And we let the three vertices be A, B, and C. Obviously, we see that the largest angle could only be the angle gamma, which is the angle between the two shorter sides, n and n minus 1. And the smallest angle could only be the angle alpha, between the two longest sides, n and n plus 1. There's one angle left, we call it angle beta. One of those angles is twice as large as another one. There could only be three different cases. First, gamma equals to 2 alpha. Second, gamma equals to 2 beta. And third, beta equals to 2 alpha. We can do this by considering sine rule. Now let's consider the first case, gamma equals to 2 alpha. Beta becomes 180 degrees minus 3 alpha. So, according to sine rule, we have n over n minus 1 equals to sine beta over sine alpha, where beta equals to 180 degrees minus 3 alpha. So, sine of 180 degrees minus 3 alpha equals to sine 3 alpha, where sine 3 alpha equals to 3 sine alpha minus 4 times sine cube of alpha. And sine square alpha equals to 1 minus cosine square alpha. So this could be further simplified as 4 cosine square alpha minus 1. We call this result equation number 1. Let's consider to use sine rule on other two sides. We have n plus 1 over n minus 1 equals to sine gamma over sine alpha. When gamma equals to 2 alpha. So, by means of sine 2 alpha equals to 2 sine alpha cosine alpha, we have such an expression equals to 2 cosine alpha. We call this result equation number 2. If we put 1 and 2 together, we get a quadratic equation in terms of n. Which could be simplified as n times open bracket n minus 1 close bracket equals to 4 times n. And we get n equals to 5, n minus 1 equals to 4, n plus 1 equals to 6, which is a set of solution of integers. Now, this may be the unique answer. Let's consider the two other cases. By sine rule again. Case 2. Gamma equals to 2 beta. And alpha equals to 180 degrees minus 3 beta. By sine rule, n plus 1 over n equals to sine gamma over sine beta. When gamma equals to 2 beta, So sine 2 beta equals to 2 sine beta cosine beta. And this expression becomes 2 times cosine of beta. We call this result equation number 3. Apply sine rule again to the two other sides. N minus 1 over n equals to sine alpha over sine beta. Now this becomes 4 times cosine squared beta minus 1, because alpha equals to 180 degrees minus 3 beta, and sine of this angle equals to sine 3 beta. Since sine 3 beta equals to 3 sine beta minus 4 times sine cube of beta, and sine squared beta equals to 1 minus cosine squared beta. That's why we get this result. We call this equation number 4. Let's put 3 and 4 together, and we get a quadratic expression in terms of n. N squared minus 3n minus 1 equals to 0. And the two roots are non-integers. So this could not be the answer. It's not an integer solution. So there's one more case left. Beta equals to 2 alpha. And gamma equals to 180 degrees minus 3 alpha. Consider two of the three sides. By sine rule, we have n over n minus 1 equals to sine beta over sine alpha. Beta equals to 2 alpha. So sine 2 alpha equals to 2 sine alpha cosine alpha. And this expression becomes 2 times cosine alpha. We call this result equation number 5. Consider the two other sides again. N plus 1 over n minus 1 equals to sine gamma over sine alpha, where gamma equals to 180 degrees minus 3 alpha. Sine of this angle equals to sine 3 alpha, where sine 3 alpha equals to 3 sine alpha minus 4 times sine cube of alpha. And sine squared alpha equals to 1 minus cosine squared alpha. So this becomes 4 times cosine squared alpha minus 1. We call this result equation number 6. Let's put 5 and 6 together. And then we get another quadratic expression in terms of n. If we further simplify, we get n equals to 2, n minus 1 equals to 1, and n plus 1 equals to 3. So this is the case of a strict line. So the only integer solution is n equals to 5. The three sides are 4 and 6 respectively. And this is proved.